So what we're going to do is we're going to review how do you graph lines, because when you solve them graphically by hand, you have to know how to graph lines. So while you're writing this down, I want you to think of 3 different ways that you have learnt graphing. 3 different ways that you've learnt how to graph a line. There's some examples there, 2 of them. How would you graph those if you had those equations? Y equals mx plus b. So if you switch it to y equals mx plus b, you have the y-intercept and the slope, then you can graph the line. Good. That's the general form, but it doesn't help you graph. Right now that is a different form, and the point slope is another form, but it's not easy to switch it to that. Y equals mx plus b is the easiest one to switch to. That's the point slope form, but it isn't easy to take this line and put it in that form isn't easy. They are easy to put into y equals mx plus b. Okay, Stephen, you got another one? The y minus y11, if it's in that form, it's easy to graph because you have a point and a slope, but it's often hard to take something and change it to that line. So that is true. If you have that form, it's a way of graphing, but these ones you wouldn't be able to put in that form. Do you remember 2 other ways? No. How about the intercepts method, where you find the x-intercept and the y-intercept and graph it? Do you remember that? And as far as a strategy goes for studying, if you can name these 3 things, so as part of your study strategy, try to name these 3, and then ask yourself if you know actually how to do those. Because the first step is, oh, intercepts method. It's good that I know that that's a method. I have no idea how to do it. Well, that's where you plug in x equals 0 and find your y-intercept. Plug in y equals 0 to find your x-intercept, and then just join those 2 lines. And for any kind of graphing, you can always make a table of values. This is not only true for lines. Next year you can use it for parabolas. Year after that you can use it for cubic functions, square root graphs, absolute value graphs, a whole bunch of different graphs. You can always make a table of values. And all you have to do is plug in a value for x and then find a value for y. For example, if I use this equation, when x is 6, what does y have to be to equal 4? 2. Good. And that would tell you 1 point on your line. If you picked another value, when x is 8, what does y have to be? 4. That tells you another point on the line. And once you have 2 points on a line, you just draw a straight line and you'd be done graphing. Table of values can be a very quick way to find a graph. What we're going to do for all of our systems of equation ones, probably the most popular one is practice our algebra to change it to y equals mx plus b, and then we'll be able to graph it from there. How do we change something from y equals mx plus b? I want you to try first. I'll give you some time, and then I'll put up the answers. Change both of those equations to y equals mx plus b. How did he do? Anyone that you'd like to go over? The first one?
I didn't even get there yet.
The first one, if we want to get y by itself, the first thing we would do is subtract 2x on both sides. That would give me negative 2x plus 3. Now to get y by itself, I'm going to need to divide by 3. If I divide this side by 3, I need to divide everything on this side by 3. And then I would get negative 2 over 3x plus 1. Second one? The second one's easier? Okay. So now that you've changed it to y equals mx plus b, what I'm going to do is I'm going to put a green box around this equation to graph it in green, and a red box around this one to graph this one in red. Do you need me to go up a little bit?
That's fine.
I can move up. It's not a problem.
All right.
Is that okay? Or is it a little bit more?
Don't know how you guys fix that. It would.
Here.
Well, you guys.
So for a green graph, we have a y-intercept of 1. That'll be the first point that you'll graph. And then since the slope is negative 2/3, that's a rise of 2, run of 3, and negative slope means it goes down from left to right. So 2 and 3, there's a point. 2 and 3, there's a point. Up 2 and over 3 this way, there's a point. Up 2 and over 3 this way. There's a bunch of points. See that they make a straight line? Connect them up. Woo! Put arrowheads on the end. And there's our first line. For the second one, y equals x minus 4, that's my red line. It has a y-intercept of minus 4. And when you have just x, what number is in front? A 1. What fraction is 1? 1 over 1. So there's your rise and your run. Up 1 over 1, up 1 over 1, up 1 over 1, and so on. And draw a line through those dots. The solution to a system of linear equations, the only value for x and y that works for both of them is the point where it intersects. And that point happens to be at 3 minus 1. That's the only x and y that works on both of those equations. All of those other points that I drew there, those are points that work on only the green one or only the red one. But the black point, 3, negative 1, is the only point that works on both of them. And that's the solution. When we think back of our questions yesterday, one of these lines could be chickens and horses equals 50. The other line would be that 4 horse plus 2 chicken equals 156. But there's only one point where both of those work.